Multiplying breakfast. Three types of multiplying breakfasts are used in names to denote multiplicity of identical figures and structures, characteristic groups, substituent groups, or terms, and correspondingly of affixes, suffixes, and prefixes in names. They are always placed before the part of the name to which they relate. Basic multiplying breakfasts denote simple figures and in general are the first choice among breakfasts to specify multiplicity. The prefix mono is not used systematically for names to indicate the presence of one nomenclature figure. For example, suffixes, prefixes, endings. It is used in functional class nomenclature to designate a monoester of digit. For example, telic acid monomentally ether, and in terminology to emphasize singleness. For example, monocyclic and mononuclear, in contrast to bicyclic and polynuclear. Derivation of basic numerical terms after Undeca number 11. Composite numerical terms are formed systematically by setting the basic terms in the order opposite to that of the constituent digits in the Arabic numbers. The composite terms are formed by direct joining of the basic terms without hyphens. The letter I in Ikosa is elided after a vowel. Example: 486 form hexaoctaconta tetracta, 6 hexa, 80 octaconta, and 400 tetracta. 14 tetrateca, 23 tricosa, 52 dopentaconta, 363 trihexacontratricta. Multiplying breakfasts for namely assemblies of identical units leading phase breakfasts are used to denote the number of repeated identical units in umbrage assemblies by third quarter, 2 by 3 third, 4 quarter, 5 quinque, 6 sexy, 7 septi, 8 octi, 9 novi, 10 deci. The list has been completed from 11 to 9,999. The prefixes are formed by changing the ending "a" of basic numerical prefixes into "I". For example, on the side 411, X at the side from 16, tetraconti 40.
The rules of nomenclatures of organic and inorganic compounds are established by the International Union of Pure and Applied Chemistry. These rules are as follows. Choose as main chain of greater length. If two strings are the same length, is taken as primary which has greater number of substituents.
The name of the alkane becomes specifying the substituents, arranged alphabetically and preceded by their respective locators. For example, in numbers 4 and 6, there are two metals. The substituents begin with the letter N, and the other substituent is alkyl that begins with the letter E. Therefore, the alkyl is the first substituent to be named. The symbols to join the locators with each substituent are the following: line or script, to join number and words, comma to separate numbers. However, when you need to write one word that follows another, you should not leave space. This is the case when the final name is written. For this example, the final name is the following: 3 script ethyl script 4, 6 script dimethyl decane. Now, for the second example, you will follow the same rules as the first example, but adding one more. When a substituent of the main chain has a substituent, the position of the main substituent, the one in the main chain, is written a dash, a parenthesis is open where the position in which the secondary substituent is inside the main substituent will be written. For example, in position 6, there is a substituent, propyl, and this has another substituent, methyl. The name of these substituents, according to the above explained, will be the following: 6 script parenthesis 1 script methyl propyl parenthesis. Finally, we order the names of the main substituents alphabetically with their respective position, and we end up placing the name of the main chain. The final name of this second example is 3 script ethyl script 2, 4, 9 script trimethyl script 6 script parenthesis 1 script methyl propyl.
In the case of having two or more substituents with the same name but that cannot be grouped, we order them via the simples, and the most complicated ones are ordered by alphabetical order of secondary substituents. As you will see in the example, the 2-hexyl substituent is less complex than 1 script ethyl hexyl. This means that 2 script hexyl goes first. After order the substituents in alphabetical order, we proceed to name the string. Alkanes with 5 or more carbon atoms are named by adding the suffix "ane" to the appropriate numerical multiplier prefix. At the end of the substituents, the name of the main chain, which is the root, is written according to the number of carbons and the termination "ane". In this example, we can see a chain of 7 carbons, which can be formed in two ways. In the first, we will have 3 substituents, which are enclosed in the rectangle, which the largest is a sec bottle and the other are a methyl. But in the second way, we can see that we have 4 substituents, 3 metals and 1 propyl. Therefore, this chain is the correct one, because it has the highest number of substituents. The chain, being of 7 carbon, is named with the root "et" and the prefix "ane". In this example, we know that the main chain is clearly the 9-carbon chain, which has 3 substituents, a metal in carbon 2 and 7, and a sec butyl in carbon 5. It is placed in alphabetical order, being first the B of butyl, then the M of methyl, and the main chain is named with the root "nona" of 9 carbons and the prefix "ane".